So how do we deal with a graph in which both the parameters a and q have changed? Let's make up an example. Y equals a half x squared minus 2. So in this case, the parameter a is a half and the parameter q is minus 2. Let's get a few x values and plot this. Minus 2, minus 1, 0, 1, 2. So substituting minus 2 into this equation, we get a half times minus 2 squared minus 2. Minus 2 squared is 4, times a half is 2, minus 2 is 0. Next we'll use minus 1. So substituting it into this equation, it's a half times minus 1 squared minus 2. Minus 1 squared is 1, times a half is a half, minus 2 it's going to be negative 1.5. If we substitute 0 into this equation, we'll get a half times 0 squared minus 2. 0 squared is 0, times a half is 0, minus 2. 0 minus 2 is minus 2. Then continuing in this way, the next point will be 1.5, and the next point will be 0. Okay, I just want to add two other points for x, 3, minus 3, and 3. If we substitute 3 into this equation, it's a half times 3 squared minus 2. 3 squared is 9, times a half is 4.5, minus 2 is 2.5. And for this positive 3, we're going to get the same thing. So whether it's negative or positive, because we square it, it just cancels out the negative. So it gives us the same thing, 2.5. So let's plot these points. So our x values go 1, 2, 3, minus 1, minus 2, minus 3. And our y values, if we just read off here, our lowest one should be minus 2, and our highest one should be 2.5. So I'm going to do minus 1, minus 2 for our lowest, and 1, 2, 3 for our upper values. So now let's plot the actual points. X equals to minus 3, y equals 2.5, so it's minus 3 for x, and then 1, 2.5 for y. Next up, minus 2 and 0. Minus 2 and 0 is there. Then we've got x equals to minus 1, y equals minus 1.5. So it's minus 1 for x, then minus 1, minus 1.5 for y. That's about there. Minus 2 and 0. And then we continue with the right-hand branch. It should mirror the left-hand branch. So 1 and negative 1.5, 2 and 0, 3 and 2.5. So our graph looks like this. Now let's talk about some of the other features of the parabola. We mentioned turning point earlier. So in this case, the turning point sits there at 0, minus 2. TP, turning point, 0, minus 2. Next, I want to talk about the roots. So we spoke about this a little bit on the phone, and the roots are where the graph crosses over the x-axis. So you can think about it like it's like roots coming out of the ground or going into the ground. So at this point, the x-axis, the value of y is 0. So you can see y goes 3, 2, 1, 0, minus 1, minus 2. So at this line over here, the value of y is 0. So to find the roots, we would substitute 0 into the original equation. We don't have to do this here because we already have the roots. So at the roots, the y value is 0, here and here. So our roots are going to be minus 2 for the x value, 0 for the y value, and the other root is where x equals to 2 and y equals to 0. So next up, I want to talk about how to find the roots and turning points given the original equation. This is because plotting the graph is quite cumbersome and you'd rather have a solid method to work it out. So let's take a look at another graph. Y equals minus 2x squared plus 2. So in this equation, we have a equal to minus 2 and q equal to 2. So how do we find the turning point? Well, for all of these graphs, the turning point lies on the y-axis. So if I just redraw the axes, x and y, we can see that along the y-axis, the value of x is 0. So if x is doing this, minus 3, minus 2, minus 1, 0, and then 1, 2, 3. So the value of x is 0. So this should ring a bell from straight line graphs where we were trying to find the y-intercept. So we set x equal to 0. And here when we're trying to find the turning point on the y-axis, we similarly set x equal to 0. Now if we substitute that into this original equation, we'll get y must be minus 2 times 0 squared, because we set x equal to 0, and then plus 2. So 0 squared is 0, times minus 2 is 0, and then plus 2 is just 2. So the value of our turning point here, TP, is going to be an x value of 0 and a y value of 2. Remember, our coordinate points are x first and y second. Next, I want to talk about how to find the roots. So we did mention a little earlier in the video, if we have a parabola that looks like this, then our roots are where the graph intersects the x-axis. And whenever that happens, the value of y is 0. So if y is going 3, 2, 1, 0, and then minus 1, minus 2, the x-axis sits where y equals 0. So to find the roots, set y equal to 0. So going back to this equation, we're going to substitute 0 where we see the y. So we get 0 equals minus 2x squared plus 2. Now we need to use some factorization tools to work this out. The first thing we can do is take out a common factor of minus 2. If we take out minus 2 from minus 2x squared, we're just left with x squared. And if we take out minus 2 from positive 2, we are left with minus 1. So if you were to do the reverse, the distribution, and you brought this 2 back in, you would get minus 2 times x squared, which is minus 2x squared, and then minus 2 times minus 1, which gives us 2. So factorization is the reverse of distributing. So we take out minus 2, and when you take out a negative from a positive, we're left with a negative. So now we factorize this using difference of squares. And it will be x minus 1, x plus 1. So now we've got this equation, 0 equals to this. And when we solve it, we need to find values of x that make each of these brackets 0. So for the first bracket, x minus 1, if x equals to 1, we will have 1 minus 1, that makes a 0, and it cancels everything. And for the other bracket, we have x must be minus 1, because minus 1 plus 1 is 0. So these are the two x values for the roots, and the coordinate points so remember, the coordinate points go x value first, y value second. So our first root has x equal to 1, and our y value is 0. The next root has an x value of minus 1 and a y value of 0. So if you were asked to sketch this graph, you've got some information, a turning point and 2 roots. So let's see what this graph might look like. So I've just kept it quite small because it's there's just so few points. So the roots are at minus 1, 0 and 1, 0, and the turning point is at 0, x equals to 0, y equals to 2. So these are the 3 points, and our graph would look roughly like this. Let me think if there's anything else I need to go through. I think that's pretty much it for parabolas. And we did talk about parabolas intersecting straight lines. Just go through that question again. If you're confused, just send me a message. WhatsApp is fine, and we can chat again on Skype. If you want to make time, I'm happy to reschedule. It's all good. So yeah, I hope this helps. I hope it's not as scary. It was very scary for me in grade 10, but yeah, hopefully you understood it. So yeah, thanks a lot, and chat soon.